Hey, YouTubers, Tazman here, bringing you another episode of Taz Teaches Java Programming, and so we've been learning quite a bit. And keep if you don't know these things or if you don't have a great understanding or whatever, uh, keep watching these. We're going to be getting into the fun stuff where we're actually programming pretty quickly, but we need to understand these basics before we can do that. You can't build a house without having all the supplies and knowing how to use those supplies. So that's what we're doing, is getting that foundation solid so we know and have good practices. Speaking of good practices, there are some good practices with Java, especially with naming conventions and how things are named. So we're going to kind of go over those really quick. In this episode, I think we're going to be kind of covering the naming conventions. We're going to talk about variables and maybe also different types of comments. So let's go ahead and begin. So first of all, I want to talk about types of cases, I guess. Maybe you have uppercase, lowercase, um, like that. So let's just talk a little bit about some of the ones that Java considers. So one is called Camel Case. So whoa, Control Z. I'm not on my pen. I'm on a gradient fill. That's funny. Okay, so if we do a CAMEL case. And Camel Case, if I were writing Word, you basically remove all your spaces. Your first word, let's do sub to me on YouTube or something. So your first letter is small, and it would be sub. And then you'd have an uppercase to me on YouTube. Oops, I misspelled tube. So there you go. So basically, Camel Case is you start with a lowercase, and then each word will have an uppercase. And that's called Camel Case. The next one is called mixed case that we're going to do. And that's mixed, mixed case. Let's draw a line under you and draw a line under you. So with mixed case, the same thing is almost exactly the same, except for it actually starts with an uppercase. Sub to me on right? So we actually, with mixed case, every word has an uppercase. So when do we use Camel Case? Generally, we will use Camel Case with our package names. With packages, maybe packages, we use Camel Case with methods. Why did I write S? I have no idea why I wrote S. I think I was thinking of subroutines. methods. So we use it with methods. We use Camel Case with variables. variables. And that is the ugliest V, right? It kind of looks like a W. So let's just erase that and hope I can make it look like a V. Burp, burp. Variables. And let's see, is that, those are pretty much it. Now we use mixed case when we're doing classes and interfaces. And we haven't talked much about interfaces, but we will. Then the last one is uppercase. And this is just what it sounds like. However, if I used uppercase on every single letter here, it would be really hard to tell exactly what it'd be just a jumble of words. So what we do in this case is, I'm just going to do sub to me because this is a lot larger. So we would do SUB, and then for spaces we actually just throw in an underscore and do TO underscore me, like that. So this would be how you do an uppercase. And generally, this is pretty much only used in constants. And just so you know, constants is just what it says. You know, we have variables which vary in their thing, and then constants in the line of variables are constant. Like, for example, a variable could be like my age, right? Because it's going to vary. So if we say my age. However, a constant might be something like pi, right? Because pi always equals 3.14 blah, 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 blah. And my age could vary. So my age could be, you know, right now it's what, 45? Next year it'd be 46. But pi is a constant. So that's kind of the difference. Your variables can vary in their value, where a constant is constant. It never changes. And these are pretty much, these are kind of both variables in a sense, or what else would we call them if not variables? I don't know. I don't know what else to call it. I mean, they're variables in a sense, but the constant is a variable that does not change. So it's a unvarying variable. Okay, whatever. So this is our different naming conventions. We use, and they're not, you don't have to use them, but it's considered best practices, all packages. So if we went and looked at some of our past things that we've done in here, you can see here's a package, all lowercase. Here's a class, it has an uppercase. If it were multiple words, it would actually be uppercase on each of them. We haven't ever done any constants, but I think, haven't we done, I think we've done some methods, haven't we? Actually, we did in private, I think. Public access, limited access. So if we go to the private one here, we have, as you notice, it's lowercase, then uppercase, because this is a method. It's a verb type thing. And all of our things here, you can see, also follow Camel Case. So these are conventions you're recommended to use because they're best practices. And it makes your code a little easier to follow and read if you're following the same thing that everybody else out there is following. So that's why they do those. So let's talk a little bit about variables in general. So in a variable, we already talked about data types. And when you're declaring a variable, which is the very first thing you do, you have to declare it. So we would say this is going to be an integer, and we're going to say it's my age, right? So this is all I need to do to declare a variable, is I just have to say, oh, I have to spell integer right, or int. I can't spell int right. So here you can see we're declaring my age. Now to assign a value or to initialize that, what we do is we would say my age and then equals 45. So now we've declared a variable and we've initialized it. We've actually set a value. Now let's just talk a little bit about what this actually is doing. So if we come here and let's grab our pen again. So when I'm doing this, if I'm declaring a variable of an integer, so I'm going to, oh, whoops, I don't want to uppercase. What am I thinking? Control Z. Get rid of that. So let's do a int and my age. What is this doing in the computer? So we're going to just draw our little representation of memory, right? Like that. I should just keep a copy of memory of what I do for memory. And then let's just go 1. Hopefully we can get 8 across, because that's generally what your bytes are. Is that 1, 2, 3, 4, 5, 6, 7, 8. So this, for example, is our little chunk of memory. I'm going to switch my color to white. So when we say int my age, the computer goes, oh, I need to reserve somewhere in memory, and I think wasn't integers 2 bytes. No, I think they were, no, I can't remember. We're going to pretend they're 2 bytes. So the computer is going to go, okay, I need to reserve a chunk of memory. Now, this chunk of memory could have who knows what in it. I mean, it could have, you know, letters, numbers. It could just have gibberish. It could actually be an old chunk of memory that was this piece right here, and this is the second half of that, or whatever. But when I say int my age, switch back to my color, boop, and then my semicolon, it's going to simply say, okay, I need to reserve a chunk of memory. And this chunk of memory is going to have the label my age. Now, to the computer, it's not actually my age. It's actually something more along the lines of 0x, you know, maybe A9, 3, 2, 6, 5. I don't know, something along these lines, 0, 1b or something like that. But what the computer's doing is saying, now my age is kind of like, think of a card catalog at a library. The books in the card catalog are not, or when they're put on the shelves and stuff, they're not put in the order of, what's the best way to explain this? Or let's just think of addresses on houses, a phone book. So my house, if I was telling people where I live, you know, and they were saying, they wouldn't just say the address on my house and not give information as to who lives there. So this is kind of the same thing. The computer knows the address by this, because each one of these things is one of these. So for example, this is B. If this was B, this would be C, D, E, F, and then it would increment to 0, and this would go to a 2, and so on and so forth. And we'll talk about that a little bit later. I have an idea on how to kind of explain that too. But anyway, what I wanted to point out is this is just telling the computer, I want this much memory, and I'm calling this chunk of memory that I want, whether it's 2, 4, 8, 6, whatever, however many bytes it is. It's telling the computer this is going to be referred to as my age for me. I'm going to call it my age. Now, when I go and later I say this, my age equals 45. So if you remember, we were talking about how binary works, and we really talk about that a lot in my other thing, in my T4zzTeaches programming logic. But with binary, it starts with 1, it goes to 2, 4, 8, 16, 32, 64, and 128, right? So if I was putting the value 45 into my age, now the computer's going to go, okay, so I need 32. There's no 16s. There's obviously no 64s. Let's see, 32 and 8 gives us 40. And then we need 5 more, so that would be 1 there, a 0 there, a 1 there, and then this would all be marked to 0, if I did that right. So now this chunk of memory actually has a value in it. And that's how the computer, anytime then I say my age, the computer knows to go to my age. So this is called, this right here is called declaring a variable. This is DECLAR. is it D-C-L-A-R, or declaration, A-T-I-O-N. So this is the declaration, and this is the initialization. I-N-I-T-I-A-L I-Z-A-T-I-O-N. This is the initialization. So we're declaring the variable, then we're initializing it. Now, if we were to try and use this variable, like if I were to say print my age, before I initialize it, whatever garbage is in there, whatever value is in there, will be output to the screen. Now, if it's a valid number, who knows? If it's not a valid number, or whatever value is there is going to be output to the screen. So it might think, I'm like 300 or something, depending on what value is in there. And like I said, we're going to I have an idea of how I'm going to show this. I'm going to have to do it in C++ to show you the memory and stuff. But I can't really do that in Java because it only has access to the JVM or the JRE, Java Runtime Environment, or the Java Virtual Machine, and that's what actually accesses the memory of the operating system. So we don't actually have direct access to operating system memory. So hopefully this kind of explains those things. So let's jump back into our guy here. And so here I'm initializing my age. Let's go ahead and say, or not initializing, sorry, D-E-C-D-E-C-L-A-R-A-T-I-O-N, declaration. And this is initialization, I-N-I-T-I-A-L-I-Z-A-T-I-O-N, initialization of our variable. Now, you can actually do this all at the same time, right? So we could actually say, let's see, let's do int favorite, favorite number, maybe, I don't know, favorite number, and you can actually stick the equals here and then put your value in there, maybe like 7 or something like that. So this is how we actually declare. So this right here is actually D-E-C-L-A-R-E, declare, and I-N-I-T-A-L-I-Z-E, initialize a variable. Now, we talked about data types and stuff. Did I misspell initialize? Maybe if I mouse over like this. Yes, I did. So there's initialize. So then there's also the rule, like we talked about this, I believe, also. So if I'm initializing a string, first, because string is a special type, it's an object type, we have to have an uppercase S in there. And then we want to give, let's see, string greet, maybe. G-R-E-E-T, so this is greet. And with strings, when we encase our value inside of quotes. So we'd say hello, like so. And this is greet, a string. The other one, most of your types like bool is either true or false. It doesn't need any quotes or anything. The only ones that really do is you have string that needs quotes like that, and you also have, oh, whoops, am I doing it? Okay, CH. We have char, and this you use a single quote, and we would say A. So left hand, oh, whoops, I forgot char, L-E-T-T-E-R, letter. Okay, so these are actually underlining now because I declare them, I might initialize them, but I never use them. I never do anything other than assign them a value, but I don't use them in any kind of other thing. Like I don't, for example, we don't say, let's say int, let's say my number, and then, for example, we say equals. So we can also, along with having just a static value, we can also do an operation. So we could say my age plus, oh whoops, I didn't do uppercase there. So my age plus, what did I say, favorite number? Favorite number. So now we're actually using both those, so they went away. But if we wanted to say S out, oops, S out, and then let's say greet. Oh, I keep wanting to do it the opposite way. So we do greet there, or we could even say S out and maybe output our letter. So if we run this, let's see if we get what we expect to get. So there we go. We have hello and A. This, we're not outputting my number, so if we wanted that, now we'd have to say S out and my number, like so. And now we could actually get all our values. So if we go 45 and 7, we get 52. So that's perfect. Here's our greeting. Here's this. So what I also want to talk about here with this, there was something else. Now I'm kind of drawing a blank. Hopefully I think of it. It's not in my notes right here. I just barely thought of it while I was typing some of this. I do know one thing I want to talk about. So there are some constraints as far as making a name. So your basic constraints, if I were to try and say int and maybe set my number to be 5 and say equals like 10, this is going to give me an error because a variable cannot start with a number. I can't even say 5 or anything like that. Variables cannot start with a number. They have to start with a number, letter, or they can actually start with the underscore. So as you can see, this guy's valid, or in other programming languages, sometimes the string is how you would signify this as a variable. So you can do either of those. It can be any word you want. I'm not going to say it can be any length you want, but I don't know of a specific cutoff length. But you want to keep them, you know, kind of so that they make sense. Like favorite number. Well, I kind of know. If I just have something called, whoops, let's put it up inside our main and say int. Actually, if I just say int this thing, and let's go ahead and do that and do a t this thing and assign that, you know, 1, 2, 3, 4, 5, 6 or 6, 5, whatever. So if I see this throughout the program, for example, I might know, oh, okay, this is going to hold favorite number. This is going to hold my age. But if this is within a program somewhere else called this thing, one, I don't even know if it's a number because I don't have to have that again when I output it. It would just say something like this, whoops, this number or this thing. So I don't even know if it's an integer. I don't know if it's a string. I don't know if it's a character. I don't know what values. So it's always a good idea to name your variables something that's meaningful, that makes sense. A lot of times you will see in programs things like variables called x. So you might see int x, or you might even see int I, or int y or z, or j. Those are really common and usually used for a counter, something that's just going to be used temporarily and go away. So you might see those, and those are the common things in counters, to use a x, a y, a z, or an I or j, but you can use anything you want. There, you know, you don't have to have a minimum limit to, you just need at least one character to assign it. Now, or one letter, I guess, or the string or the underscore. Although I don't think, let's try something real quick. Can we actually just, that'd be terrible. Int underscore equals 5. Is that valid? That is valid. Or you could do like string $sign equals goodbye. And so that's valid too. Oops, I put that semicolon in the wrong spot. So as you can see here, there are some constraints as far as what you can name things. Obviously, you can't name something class, you can't name it int. There's actually 50 things that you're not allowed to name your variable. And let's just pull those up right here. Oops, wrong one. Right here. And get rid of this one too. So these are reserved keywords in Java, and there's 50 of them that you really can't use for a variable name. Now, if I said like fort, it's not going to care about the for in there because it's just looking at for. So as you can see, abstract, assert, boolean, break, byte, case, catch, char, class, const, continue, default, do, double, else, and enum, extends, final, finally, float, for, go to, if, implements, or import, instance of, int, interface, long, native, new, package, private, protected, public, return, short, static, strict FP, super, switch, synchronize, this, throw, throws, transient, try, void, volatile, and while. So you can't use any of those in the naming of your variable. So just remember that. And you can also find this like online. You can go look up Oracle's Java information and find it there too. Let's see. So is this everything I want? No, I want to do some other things really quick. So constants generally are going to be more of a global variable. So we're going to talk about scope a little later. I don't think we have time right now. But scope is, remember how we talked about encapsulation and how things are public, private, and protected, and the default? Well, scope is where those things are visible from as a default. And generally, the brackets kind of instigate what is your chunk of code. And things within brackets can see inside their parent bracket, but not necessarily outside. So if I want to do a constant, which means everything can see it, if I have my main class here, variables, I would want to type like public, because I do want this thing to be completely public. And then I would do, I probably need static first too, static, just because we're within our main thing and stuff. And then we would call it final. Wait, is it public final static? Let's see, maybe I don't need the final here. Maybe it's if I'm declaring it inside theirs. I can't remember. I'll look it up. So I could do public final, and final means this is the final version of this variable. Whatever I name this, or whatever value I give this, that's it. So if I said pi, and this is where we said that it's all uppercase with underscore separating it, and we say 3.14 and do that. Oh, I know what I'm missing. I'm missing the type. Public final, I think int is, whoops, final. Oops, I'm not in insert mode. And then int. So something like that. Oh, whoops, not int, because that's a decimal. DOU double, and I way messed that up too. So there we go. That means if I tried to change this, like if I was in my program down here, and I say pi equals 3.15, this is going to throw an error because it's a constant. It's going to say, hey, stupid, can't make a static reference to a non-static field. Okay, maybe we should make this public. I think I use static, public static final. There we go. Well, we're still going to get an error here because final cannot be assigned because it is a it's a constant. The final variable pi cannot be assigned because it's constant. Now it also shows you here that when it's constant in the not texture pack, the styles that I use for this, it kind of makes constants the same color as out here, where variables are usually this lighter color. And you might even notice when I first set up a variable, it's at even a lighter color. So this is where I initialize the variable, or declare the variable. This is where I use the variable. And see, I'm using the variable here as well. So it's kind of nice how this works, and you know, the coloring and stuff with this theme that I use. Let's see. So is that everything else? No, I wanted to do one other thing. So the other thing I wanted to point out is these right here are called comments. And you can do comments. Code is completely ignored when it's a comment. There's three basic types of comments. We have this one, which is double slash, and then you can type whatever you want after that. That comment is called a single line comment. If, for example, I was testing my code, the phone, dang it, sorry. If I were testing my code and I need to comment out a chunk, I can use what's called a multi-line chunk comment, which is a / and a star, and then you tell it where to end by doing the opposite, a star and a /. And now this whole chunk of code is no longer run. Let's comment this guy out, like so, because this program would not run the way it was in. But now you'll see this isn't going to output anything because all my outputs are commented out. And we're not erroring out because this guy is commented out. Now, another thing you might notice, like if we go and mouse over, for example, where is one? Well, let's do main here. Or where can I do one? Actually, let's do it. Where's my S outs? Right here. So if I mouse over the different components, let's just leave one of these, like so. So see this little pop-up right here? This is called JavaDoc statements, and it helps you understand what you need to do. So as you can see here, void java io, print stream, print ln, and it expects, or its parameter it wants you to give it is a string, and then they're just calling it X because they don't care about that. If we hit F2 right here over this guy, we can actually change it, and you can see that it tells you a little bit about it. It says prints a string, then terminates the line because we have the ln in there, as though it invokes print string and then print ln. So print actually is the one that is doing the string. The println itself just adds a line, but they've made it so this kind of invokes that kind of thing. Not sure if that made sense to you, but it's not that important to understand. But let's figure out some how we would do something like that ourselves. So let's say I have a subroutine out here, and let's just call it, or a method, sorry. We'll have a public, and it's going to return nothing. Oh, we need static because it's part of the main one. So we do static, and then it's going to not return anything, and we're going to call it test, right? And we're going to have it get variables. Actually, let's have it return too, just so I can show you that. Let's have it do an int. It's going to return an integer, and let's have it take an int, and we'll call this my age. Oops, age. Oh, we're over time. Let's do maybe int my height. I don't know, or maybe double. I don't know. Would I do? Yeah, I guess I'd be a double. POU double. This really doesn't matter. My HEIGHT maybe. And let's also do a string maybe. A string called my name. So this subroutine here, when it's called, it expects me to pass it 3 variables, 3 parameters. And the reason this is red right now is because here I'm telling it returns a type. Now we really haven't gone over methods and such. We will later, but what I wanted to point out mostly is the Java doc functionality. So what this is saying is, here I'm saying it's going to return an integer, but I'm never doing it. So this is saying this method returns a result of type int. So it's expecting me to return something, and we're just going to say my age for now. Now, if I create a method kind of like this, and then I decide after I want to add a Java doc, this is the best time to do it because it'll actually fill in some of the Java doc information for you. And the way you do it is you do a /*, like so, and then you hit enter. Now you'll see what this is doing is it automatically detected that I have these 3 integers and I'm returning my age. Now one thing I like to do, and you can actually even say comment up here saying this is a cool method that does stuff. I don't know. Does stuff. And then we can actually give a little more information. I kind of like putting like a dash here and then saying this is an int and say, you know, age of the user, something like that. And then maybe height of the user, so this is a dash int height of the user, and so on and so forth. This is a str string, and say name of the user. And maybe just to make things more clear, I might stick these all in parentheses just so it doesn't look like int is actually part of the description type thing. And then as you can see here, it says it's returning, but this doesn't actually say anything. So we could say int, or parentheses, and maybe something like this and say RET, yeah, sure, RETUR returns the age of the user. So what's neat about this is now if I'm up here in a whole nother part of my program, you know, if I have another class or something and I want to access that, because I know the actual name, which is test, right? I could say, let's see, let's do well, let's just use the my age, because it wants something to return, we need to put it somewhere. So we're going to say my age equals TS, and if we hit tab enter, we can see here it has our thing. And we can also see if we mouse over this, we get that same information right here. So as you can see, we have all our thing here saying this is the main thing, showing what it's expecting. Int variables, because it's inside the package, inside the class, and it's called test. It expects int my age, int double, string my name, and then here's our description. Here's the parameters. So my age is an integer, age of the user. My height is the height of the user. So if these are a little less common, like if this is more generic, we might have something in here like this. And then we can also see here that it returns an integer, which is the age of the user. So we can actually see, and then also see, because we have, well, this isn't because of the Java doc, because we created this first, it also automatically generated the my age, my height, my name variables here to also help you know that this is, the first parameter is expecting my age is what I'm calling it here. Now, it's also important to know that once this my age could be the same as this my age. If I pass this my age here, however, if I have this my age here, it is not the same as this. And we're going to talk about that when I show you how the memory works and stuff. It's not like in this because we don't have a variable called my height and we don't have a variable called my name. That's why we're getting the errors on there. All right, so I think we just covered a whole ton of stuff, and it's 40 minutes, so I apologize for that. But we did cover a lot of good and important stuff. So hopefully you guys enjoyed this and you're learning something good. And if I'm making any mistakes, feel free to correct me. I'm not perfect. I'll be the first to admit that. I don't know everything about this. And there's probably even things that maybe you could teach me that I'm doing the least efficient way or inefficient. So, like I said, if you guys did enjoy it, be sure to leave a thumbs up down below. Aside from that, comment, like, and subscribe. Follow me on Twitter. Check out my other channels for other fun videos and stuff. And that's it. Until next time, I'll be seeing you later. Bye.